This is Physics 30, Chapter 1, Lesson 3, talking about equations of motion. So when we're talking about equations of motion, we have four primary ones that we are interested in, which you can see on the screen in front of you. Vf means velocity, and Vi is also velocity. The subscripts f and I are used to denote final and initial. So the first formula is telling us that the final velocity will be equal to the initial velocity plus the acceleration multiplied by time. In the other formulas, Vi and Vf stand for the same thing. A stands for acceleration, T for time, and D for displacement. Gravity is a constant acceleration in the universe, and it's measured at approximately 9.81 meters per second squared. So in the example on the right here, we see that if you drop a ball from this cliff, when time is 0 seconds, the velocity will also be 0, so that would be like the moment right before the ball is dropped. Then after 1 second, the velocity has increased to 9.8 meters per second. And then every second after that, the velocity will get 9.81 meters per second faster. Looking at one example here, a bullet is fired straight up at a velocity of 50 meters per second, and the question is, how high does it go? Whenever we have a question like this, it's a good idea to list all of the things that you know first, as well as what you're looking for, and then we can compare that list to the equations that we saw previously, trying to determine which equation will be the best for a given scenario. Now, we're thinking about just the total height that the bullet goes, so just from the point of firing up until the peak of the arc. If you think of firing a bullet kind of like a parabola, you would fire it from down here, it would go up, reach some peak, and then come back down. We're really only looking for half of this scenario, which is the part of the bullet going up to its highest peak. So knowing that, we can say that the initial velocity will be 50 meters per second. That's the firing speed. And when the bullet stops its ascent, when you fire it, gravity immediately takes over and starts to slow it down, and eventually it will stop going up, turn around, and start coming down. At that point where it stops going up, the velocity would be 0, because it has to change from going up to coming back down, so there must be some 0 point. So we can say the final velocity is 0 right at the peak of it being fired, and the acceleration due to gravity will be negative 9.8 meters per second squared. We say negative because the gravity is slowing down the bullet. On the way down, gravity would actually be a positive because it will be working to speed up the bullet on the way down. And we're looking for D. We're looking for the total displacement of the bullet. So knowing these things, you can pause here for a second if you want to try and figure out which of your equations would be best suited to this problem. But we're probably going to go with this one. Vf squared equals Vi squared plus 2AD. So just rearranging slightly, we can move the Vi squared to the opposite side. Then we can divide both sides by 2A, giving us an equation for displacement. Then plugging everything in, final velocity being 0, initial velocity being 50, and A being negative 9.8, we can simply then calculate that our displacement will be 127.6 meters. Continuing the same example, how long is the bullet in the air? Well, for this we can use the equation Vf equals Vi plus At. We need some equation here that has t because now we're looking for time. So, rearranging again, we can move Vi to the other side. We can divide both sides by A, and we will have an equation for time. Again, we know that the final velocity is 0, the initial velocity is 50, and the acceleration is negative 9.8. So solving all of this, we can say that the time will be 5.1 seconds. However, remember that we're only looking at the part of the scenario from the moment the bullet is fired up until the peak of its climb and when it starts to come back down. So because acceleration of gravity is a constant, the same rate that it slows the bullet down as it goes up is going to be the same rate it accelerates the bullet as it comes down. So your time going up and your time coming down will be the same thing, meaning that the total time to go up and back down is 10.2 seconds. For an assignment and some practice, we're going to look at page 21, numbers 1 to 8, doing any 6 of those.